Take a slow, deep breath in, allowing the tension to simply drain from your muscles as you exhale. Let your body settle completely into the quiet comfort of this space, sinking into the soft weight of gravity. Imagine resting just against your chest or curled upon your lap, the familiar comforting form of a domestic cat, known scientifically as Felis catus. The very first thing you notice is the radiating heat, a deep and steady warmth that transfers smoothly from their body to yours. The internal body temperature of a healthy domestic cat hovers between 100.5 and 102.5 degrees Fahrenheit, or 38.1 to 39.2 degrees Celsius. This temperature is significantly warmer than our own human resting temperature, which is why a sleeping cat feels like a living, breathing hearth against your skin, melting away the chill of the surrounding night. As your hand gently brushes across their sleeping form, you encounter the marvel of their coat. A cat's fur is a masterpiece of biological engineering, capable of possessing up to 130,000 individual hairs per square inch. This incredibly dense forest of fur acts as a perfect thermal insulator, trapping that 102-degree body heat close to the skin. This coat is primarily composed of two distinct types of hair. Your fingertips first glide over the longer, slightly coarser guard hairs, which evolved over millennia to protect the animal from moisture and harsh environmental elements. But as you press just a fraction of an inch deeper, your skin meets the soft, downy undercoat, made of incredibly fine strands, known as awn hairs. It is this dense, microscopic matrix of awn hairs that creates the sensation of touching pure, spun silk, yielding perfectly to the gentle pressure of your palm. And then, rising up through that silken warmth, comes the sound. The contented purr of a house cat is one of the most soothing acoustic phenomena in the natural world. It typically registers at a gentle acoustic volume of 25 to 50 decibels. To put that into perspective, 25 decibels is roughly equivalent to the volume of a quiet whisper in an empty library, or the faint, distant hum of a modern refrigerator. It is a sound that does not demand your attention, but rather gently invites your nervous system to quiet down and align with its steady rhythm. The mechanics behind this mesmerizing vibration are an exquisite display of biological clockwork. Deep within the cat's throat, the laryngeal muscles are engaged in a microscopic rhythmic dance. Driven by a specialized neural oscillator located in the cat's brainstem, these laryngeal muscles begin to twitch at an astonishingly rapid rate, precisely 20 to 30 times every single second. This rapid, repetitive twitching creates a sudden, tiny separation of the vocal cords. Here is something truly remarkable about the anatomy of the purr. As the sleeping cat breathes in and out, air is constantly pulled across these rapidly twitching muscles. Unlike human vocalization, which happens almost entirely when we exhale, cats utilize a continuous airstream mechanism. They purr seamlessly on both the inhale and the exhale. This creates a perpetual, unbroken cycle of sound, an endless loop of acoustic warmth that mimics the steady, predictable rhythms of planetary orbits or the gentle tidal wash of an ancient ocean. The sound waves generated by this laryngeal flutter travel outward into the air at approximately 343 meters per second, or 767 miles per hour. Despite this incredible velocity, by the time these acoustic waves travel the short distance to your eardrum, in a mere fraction of a millisecond, they arrive as a slow, rolling wave of pure comfort. But the frequency of the domestic cat's purr is where the true, scientifically verifiable magic lies. Biologists and acousticians have measured the frequency of the feline purr to fall consistently between 25 and 150 Hertz. This specific bandwidth of acoustic energy is not arbitrary. In the fields of veterinary medicine and biomechanics, researchers have discovered that frequencies exactly in the 25 to 50 Hertz range and the 100 to 200 Hertz range have profound physiological healing effects. Exposure to these specific low frequencies has been clinically shown to improve bone density, reduce joint inflammation, and actively promote cellular tissue regeneration. When a cat is resting and purring, they are essentially bathing themselves, and whoever they are resting upon, in a localized, low-frequency healing field. This vibration originates in the throat, but travels seamlessly through the cat's entire skeleton. A domestic cat possesses a highly flexible skeletal structure containing approximately 230 to 250 individual bones, significantly more than the 206 bones found in the adult human body. This astonishing flexibility is aided by a fascinating evolutionary adaptation. The cat lacks a rigid collarbone. Their clavicles are free-floating, attached to the rest of the skeleton only by a soft web of muscle and connective tissue. Because of this loose, suspension-like anatomy, the physical vibration of the purr is completely uninhibited. It rolls freely through their ribcage, down their spine, and out into the surrounding environment, turning the entire animal into a soft, resonating instrument, vibrating with life. As the cat rests lightly upon your chest, this 25 to 150 Hertz vibration transfers directly through their fur and into your own skin. Just beneath the surface of human skin lie specialized sensory nerve endings, known as Pacinian corpuscles. While these microscopic onion-shaped tactile receptors are exquisitely tuned to detect sudden shifts in pressure, they also capture the deep, sustained, rhythmic rumble of the cat's purr. The Pacinian corpuscles absorb this mechanical energy and elegantly translate the physical pressure into electrical signals, sending a cascade of calming rhythmic data straight up your spinal cord to your brain. The internal effect of this rhythmic tactile stimulation is beautifully measurable. The physical presence, warmth, and sound of a purring cat triggers the release of oxytocin in the human brain. Oxytocin is a powerful neuropeptide, frequently referred to in neuroscience as the bonding hormone. As your brain slowly releases oxytocin, your blood vessels gently dilate, which naturally and safely lowers your blood pressure and actively slows your own heart rate. Simultaneously, the cat's own brain is releasing a steady stream of endorphins, endogenous opioid peptides that act as a natural painkiller and relaxant for the animal. It is a perfect symbiotic loop of chemical peace, a silent biochemical conversation shared between two entirely different species. Consider the vast expanse of time that has led to this quiet moment in the dark. The domestic cat has lived alongside humanity for approximately 10,000 to 12,000 years. Archaeological evidence, including ancient human and feline burials found in the Fertile Crescent of the Middle East, suggests that this delicate relationship began at the very dawn of human agriculture. For over 100 centuries, humans and cats have shared the stillness of the night, bound together by the comforting, predictable rhythm of the purr. It is a sound that comforted our ancestors, exactly as it comforts you now, a constant acoustic thread woven through the tapestry of human history. Beneath the constant 25 Hertz hum of the laryngeal twitch, there are other, deeper rhythms at play in the sleeping animal. The resting heart rate of a domestic cat beats rapidly, typically between 120 and 140 beats per minute. If you focus, you can feel it, a quick, steady internal drumbeat that underscores the slow wash of the purr. Layered perfectly over this is their breathing. The normal respiratory rate of a resting feline falls exactly between 15 and 30 breaths per minute. You can feel this gentle rise and fall against your body, a rhythmic expansion and contraction of their tiny ribs that perfectly mirrors the slow, inevitable expansion of a quiet, sleeping universe. It is a quiet luxury that belongs uniquely to these smaller felines. In the vast taxonomy of life, big cats belonging to the genus Panthera, such as lions, tigers, leopards, and jaguars, cannot purr continuously. Due to a distinct anatomical difference in their hyoid bone, which in the Panthera species is partially composed of flexible cartilage rather than solid bone, these apex predators are equipped to roar, projecting their massive power across great distances. It is only the smaller cats of the Felis genus, along with cheetahs of the Acinonyx genus, that possess the hardened, completely ossified hyoid bone required to maintain this continuous, soothing vibration. Through the slow march of evolution, they traded the booming roar of the wild for the gentle, unending hum of contentment. As you lie here, attuned to this microscopic biological symphony, allow your own body to harmonize with the sound. Feel the steady 102-degree warmth seeping into your skin. Focus on the low, 25 Hertz vibration, gently rocking your senses. Picture the incredibly soft texture of 100,000 silken threads resting against you. The sleeping cat is a masterpiece of biological physics, a miniature cosmos of sound, heat, and sensation, inviting you to let go of the day, to release your thoughts, and to drift deeper and deeper into a state of absolute, undisturbed peace. This steady, rhythmic vibration, radiating from the small creature resting nearby, functions much like a biological pulsar. In astrophysics, a pulsar is a highly magnetized, rotating neutron star that emits a precise, unending beam of electromagnetic radiation, pulsing with the reliability of an atomic clock. Here, in the quiet of the room, the feline purr acts as an acoustic pulsar, sending out perfectly timed waves of mechanical energy into the dark. To understand the sheer scale of this biological mechanism, trace the phenomenon back to its evolutionary dawn. The genetic lineage of all modern purring cats diverges from a common ancestor known as Proailurus, a prehistoric carnivore that roamed the dense ancient forests approximately 10.8 million years ago. For over 10 million years, this specific acoustic frequency has echoed through the undergrowth of our planet, passing continuously from generation to generation. It is a biological continuum, an ancient song of survival and comfort that remains completely unchanged by the passing of epochs. Records indicate that human fascination with this sound stretches back to the earliest cradles of civilization. By 2890 BC, during the Second Dynasty of ancient Egypt, cats were already highly revered, eventually becoming associated with the goddess Bastet. The Egyptians observed the nocturnal habits of these animals, noting their mysterious ability to navigate absolute darkness and their unique, vibrating hum. Yet, for millennia, the exact physical mechanics of the purr remained an unsolved puzzle, a secret kept hidden beneath layers of fur and muscle. It was not until the 19th century that science began to systematically decode the mystery. In 1834, the renowned British anatomist Richard Owen published early, detailed observations on the unique structure of the feline larynx. He carefully mapped the delicate cartilage and specialized vocal cords that differentiate small cats from their roaring cousins. A few decades later, in 1872, The naturalist Charles Darwin devoted a section of his seminal work for the expression of the emotions in man and animals, specifically to the feline purr. Darwin astutely recognized the sound as a homophonic vocalization, a sound characterized by a single continuous primary tone, and correctly categorized it as an innate, evolutionary expression of absolute contentment and social bonding. Despite these Victorian-era discoveries, the precise internal clockwork driving the vibration eluded scientists for another century. A breakthrough occurred in 1991 when researchers Sissom, Rice, and Peters utilized a technology known as electromyography, or EMG. By measuring the microscopic electrical signals traveling through feline muscle tissue, they definitively proved that the purr is not just passive airflow, but an actively driven neurological rhythm. Their EMG readings revealed that the neural oscillator, situated deep within the feline brainstem, fires an electrical command every 30 to 40 milliseconds. This translates to an astonishingly precise rhythmic contraction of the laryngeal muscles. What the 1991 study also unveiled is the profound energetic efficiency of this process. Unlike shivering, which requires a massive expenditure of metabolic energy to generate heat, the neurological and muscular process of purring consumes virtually no additional caloric output. The cat maintains this steady 30-millisecond rhythm in a state of deep metabolic rest. It is a perfectly balanced system of perpetual biological motion, costing the animal almost nothing while providing profound physiological benefits. Consider the journey of an infant kitten, a scenario that perfectly illustrates the original evolutionary purpose of this sound. In the 1960s, German ethologist Paul Leihausen extensively categorized feline behavior, defining the purr originally as a vital contact call between a mother and her offspring. When kittens are born, they are highly altricial, meaning they are completely helpless. A newborn kitten's eyes are tightly sealed, only beginning to open after 7 to 10 days of life. Furthermore, their ear canals remain closed for 10 to 14 days, rendering them functionally deaf to airborne, high-frequency sounds. Yet, remarkably, a kitten begins to purr when it is merely 2 days old. The mother cat surrounds her blind, deaf newborns with a low, continuous vibration. Because the kittens cannot see or hear in a conventional sense, they rely entirely on their tactile nerve endings to navigate. They feel the deep, rolling vibration of their mother's 25 Hertz purr, moving through the solid floor and through the warmth of her body, using this mechanical wave as a precise biological beacon to find nourishment and safety in the dark. Through the lens of physics, the acoustic footprint of this sound is vast. A sound wave vibrating at 25 Hertz possesses a physical wavelength of approximately 13.7 meters, or roughly 45 feet. This means that as the cat breathes and pulses, a single wave of acoustic energy stretches completely across the room, gently rolling over the walls and furniture, moving through the atmosphere like a long, invisible oceanic swell. You are currently resting inside the trough and peak of a 45-foot physical wave of air pressure, a slow, invisible tide created by the tiny animal beside you. Woven within that massive 13.7-meter primary wavelength are layers of acoustic complexity. Acoustic analysis reveals that the domestic cat's purr is rich in harmonic overtones, while the fundamental frequency rests firmly at the low end of the spectrum. The physical shape of the cat's nasal cavity and skull causes the sound to resonate, producing fainter, secondary frequencies that reach all the way up to 1000 Hertz. These higher overtones add a rich, textured timbre to the sound, turning a simple mechanical hum into a complex, multi-layered symphony of air pressure. Even within this comforting rhythm, evolution has woven subtle tools of communication. In 2009, behavioral ecologist Dr. Karen McComb discovered a highly specialized variation of the purr. He's scientifically termed the solicitation purr. Dr. McComb's acoustic analysis revealed that when a cat is actively seeking food or attention, they embed a high-frequency acoustic peak measuring between 220 and 520 Hertz directly into the low-frequency rumble. This specific high-frequency band perfectly matches the acoustic pitch of a human infant's cry, subconsciously triggering a nurturing response in the human brain. But in a state of rest, that high-frequency urgency simply falls away, leaving only the deep, flat, harmonic baseline of pure tranquility. As this baseline vibration continues its rhythmic pulse, it initiates subtle changes in the local environment of your own body. Scientific measurements indicate that the steady application of a 25 to 50 Hertz mechanical vibration stimulates vasodilation in mammalian tissue. The microscopic smooth muscles lining your capillaries gently relax, which can increase localized blood flow by up to 20%. The gentle warmth you feel spreading from the cat is not just their 102-degree body heat. It is your own circulatory system responding to the mechanical energy of the purr, slowly expanding your vessels and delivering oxygen-rich blood to your resting muscles. Simultaneously, this frequency interacts directly with the molecular structure of bone. In the field of biomechanics, a 25 Hertz mechanical wave passing through the skeletal system simulates a mechanical stress load equivalent to roughly 0.5 g-forces. This specific physical pressure is enough to stimulate osteoblasts, the specialized cells responsible for bone synthesis and mineralization. As the acoustic wave travels from the feline skeleton into yours, it provides a microscopic therapeutic massage to the very calcium matrix of your bones. Visualize the room around you, bathed in darkness, yet teeming with invisible sensory information. If the cat were to suddenly open their eyes in this low light, you would witness another marvel of their nocturnal biology, the tapetum lucidum. This specialized, highly reflective layer of tissue sits perfectly behind the feline retina. It acts as a biological mirror, capturing ambient photons of starlight or moonlight and reflecting them back through the photoreceptor cells a second time. This reflection often bounces back at a specific optical wavelength of roughly 500 nanometers, which human eyes perceive as a luminescent golden-green glow. Coupled with their vision is a masterful sense of chemical detection. In 1811, the Danish anatomist Ludvig Levin Jacobsen discovered the vomeronasal organ, a specialized patch of sensory cells located in the roof of the feline mouth. This organ allows the resting animal to essentially taste the chemical composition of the air, processing complex pheromones and environmental data without ever needing to rise from their sleep. They are perfectly designed to rest in the dark, safely monitoring the invisible currents of the room while maintaining their rhythmic 30-millisecond muscular pulse. There is a profound beauty in this slow, repetitive clockwork. The rising and falling of their ribs, the steady 120 beat per minute flutter of their tiny heart, and the 45-foot acoustic wave rolling silently through the atmosphere, all combine to anchor this moment in space and time. It is a system perfected over nearly 11 million years of evolution, designed to conserve energy, promote physical healing, and project an atmosphere of utter safety. The ancient vibration continues, wrapping the room in a heavy, comforting blanket of sound, inviting the surrounding world to finally pause and match its slow, deliberate pace. To fully appreciate the sheer mechanical elegance of this resting creature, we must follow the invisible currents of the room as they are drawn inward, fueling the quiet engine of the purr. At the very center of this biological cosmos lies the feline respiratory system, a masterclass in fluid dynamics and gas exchange. Observe the slow, steady flare of the cat's nostrils. With every inhalation, a tiny, precise volume of the surrounding atmosphere is pulled into the nasal cavity. Biologists measure this single, resting intake, known as the tidal volume, at approximately 12 to 15 milliliters of air per breath. To grasp the scale of this, imagine the liquid volume of a standard tablespoon or a small plastic medicine cup. That tiny pocket of air represents the exact quantity needed to sustain the intricate clockwork of their resting body. As this 15 milliliter pocket of air enters the nasal passage, it immediately encounters a labyrinth of intricate scroll-like skeletal structures called the nasal turbinates. These delicate bones are draped in a highly specialized mucous membrane. Think of a modern climate control system in a luxury building, instantly adjusting the humidity and temperature of incoming air. The turbinates perform exactly this function. Jetson. They rapidly warm the incoming room temperature air to match the cat's internal 102-degree core, while simultaneously adding moisture, ensuring that the delicate tissues deeper within the lungs are never shocked by cold or dry drafts. Situated directly within this nasal labyrinth is the feline olfactory epithelium, the sensory tissue responsible for their incredible sense of smell. In an adult domestic cat, this tissue spans approximately 20 square centimeters. If you were to lay it flat, it would cover the surface area of a large, standard postal envelope. By comparison, human olfactory tissue covers only about 3 to 4 square centimeters, roughly the size of a single postage stamp. Packed densely within the cat's expansive sensory envelope are up to 200 million individual scent receptors. Even in the depths of sleep, this vast array acts as an open passive radar, continuously monitoring the chemical composition of your home. Once conditioned and analyzed, the air travels down the trachea, reaching speeds of roughly 1.5 to 2 meters per second. The feline trachea is structurally reinforced by an arrangement of 38 to 43 C-shaped cartilaginous rings. Much like the ribbed exterior of a flexible vacuum hose, these rigid rings ensure the airway remains perfectly open and unobstructed, even when the cat is curled into an impossibly tight, spherical shape. Deep within the chest cavity, the airway splits into the left and right bronchi, branching infinitely smaller, like the sprawling limbs of a microscopic oak tree, until the air finally reaches its destination, the alveoli. A healthy domestic cat possesses an astonishing 300 to 400 million of these microscopic, balloon-like air sacs. Picture this anatomical marvel for a moment. If you were to carefully unfold and lay flat the delicate membrane of all 400 million feline alveoli, the total surface area would measure between 2 and 3 square meters. This means that housed within the tiny resting chest of the animal beside you is an internal respiratory surface equal to the size of a large dining room table. It is across this vast hidden table that the fundamental alchemy of life occurs. The membrane wall of an alveolus is unfathomably thin, measuring approximately 1 single micrometer across, which is less than 1/50th the thickness of a human hair. Because this barrier is so thin, the gases within the 15 milliliter breath can effortlessly pass through it. The inhaled air is composed of roughly 78% nitrogen and 21% oxygen. Through the silent, passive physics of diffusion, the oxygen molecules slide through the 1 micrometer wall and bind instantly to the iron-rich hemoglobin proteins waiting inside the feline red blood cells. Simultaneously, carbon dioxide, a byproduct of cellular metabolism, drifts in the opposite direction. The air that the cat subsequently exhales out into the room now contains roughly 4 to 5% carbon dioxide. This molecular swap happens seamlessly, 15 to 30 times a minute, driven by the rhythmic, muscular bellow of the feline diaphragm. The diaphragm itself is a dome-shaped sheet of skeletal muscle that partitions the chest cavity from the abdomen. In a domestic cat, this vital muscle is incredibly thin, measuring a mere 2 to 3 millimeters in thickness. Yet, it operates with absolute, untiring precision. As it flexes downward, it creates a vacuum within the total lung capacity, which maxes out at a volume of 100 to 150 milliliters, roughly equivalent to the liquid held in a delicate china teacup. Once the oxygen is securely bound to the red blood cells, the feline circulatory system takes over. The resting feline heart, beating its steady 120 beats per minute, acts as a powerful, rhythmic pump. It propels these oxygen-laden cells out to the furthest extremities of the body. The velocity of this internal transit is truly remarkable. A single red blood cell in a cat can complete an entire circulatory circuit, traveling from the heart down to the tip of the tail and back again in just 11 to 14 seconds. As the air is gently exhaled back into the atmosphere, it carries a small amount of internal moisture with it. Over the course of a 24-hour cycle, a resting cat will naturally lose approximately 20 to 30 milliliters of water vapor simply through the act of breathing. This warm, humidified exhaust flows gently over the cat's face, silently interacting with another highly engineered sensory apparatus, the whiskers, known in the scientific community as vibrissae. Whiskers are far more than ordinary hair. They are an advanced tactile sensor array, functioning much like the sensitive antennae of an insect or the precisely tuned strings of a harp. An average domestic cat features exactly 24 mystacial whiskers on their muzzle, distributed symmetrically with 12 on the left and 12 on the right. Look closely at how these are arranged. The 24 mystacial whiskers grow in 4 distinct horizontal rows. In a remarkable feat of neuromuscular isolation, the upper 2 rows of a cat's whiskers can be flexed and moved entirely independently of the lower 2 rows. The structure of the vibrissae reflects their critical importance. Composed of heavily compacted keratin, a single whisker is 2 to 3 times thicker than a standard guard hair. But their true power lies beneath the surface of the skin. The root of a whisker is planted up to 3 times deeper into the facial tissue than an ordinary hair follicle. At this profound depth, the base of every single whisker is entirely encapsulated by a specialized structure known as a blood sinus. Think of this blood sinus as a microscopic pressurized fluid shock absorber. When a physical object, or even a subtle shift in air pressure, touches the tip of the whisker, the stiff keratin shaft acts as a lever. This movement travels down into the root, pressing against the blood sinus. The liquid within the sinus elegantly amplifies this microscopic mechanical movement, pushing it into a dense web of tactile nerve endings called proprioceptors. This liquid amplification system is so unimaginably sensitive that a cat does not even need to touch a solid object to perceive it. Their vibrissae can detect ambient air currents moving at a velocity of just 1 millimeter per second. To put that into perspective, Imagine trying to physically feel the microscopic draft created by a single dry leaf falling slowly to the ground from a nearby tree. The cat processes this data effortlessly as the acoustic wave of their own 25 Hertz purr and the slow 15 milliliter exhalation of their breath displaces the air in the room, their whiskers red, the returning echoes, painting a highly detailed, three-dimensional topological map of the immediate environment directly onto their sensory cortex. These incredible streams of biological data, the chemical analysis of the 200 million scent receptors, the barometric pressure readings of the vibrissae, the rhythmic gas exchange across the 3 square meters of alveolar tissue, are all routed through the feline nervous system without demanding a single conscious thought. It is the absolute pinnacle of automated resting physiology. You are currently sharing a quiet space with a living, breathing sensory masterpiece. As you listen to the rhythmic intake and exhale of their breath, consider the invisible complex clockwork sustaining it. A tablespoon of air, pulled down a flexible cartilaginous hose, distributed across a microscopic dining table of cells, feeding a heartbeat that circulates life every 14 seconds. Allow the quiet perfection of this machinery to ground you in the present moment, anchoring your own breath to the slow, steady rhythm of this ancient purring companion. At this very moment, as you feel the slow rhythmic expansion of the ribcage beneath your hand, it is essential to trace the energetic origins of this biological engine. The purr, the 102-degree warmth, and the meticulous regeneration of bone density are all fueled by the specific diet and highly specialized digestive tract of an obligate carnivore. Unlike omnivores or herbivores, the domestic cat, Felis catus, has evolved over thousands of millennia to extract the vast majority of its metabolic energy and essential hydration directly from animal protein. Notice how perfectly tailored their internal chemistry is for this specific task. Deep within the feline stomach, the gastric acid maintains an astonishingly corrosive pH level of roughly 1.0 to 2.0. Think of industrial-grade battery acid. The feline stomach acid is nearly as potent. This incredibly acidic environment serves two crucial evolutionary purposes. First, it acts as an impenetrable biological firewall, swiftly neutralizing potentially harmful bacteria like Salmonella and E. coli that might be present in raw prey. Second, it efficiently denatures complex animal proteins, breaking down tough meat and even small bones into easily absorbable amino acids within a matter of hours. Picture this process as a highly specialized internal refinery, operating silently while the cat sleeps. The length of a domestic cat's intestinal tract reflects this rapid refinement process. In human anatomy, our long, winding intestines can measure up to 20 feet or more, designed for the slow, laborious fermentation of complex plant matter and carbohydrates. Conversely, the entire feline intestinal tract is relatively short, measuring only about 1.2 to 1.7 meters in length. This abbreviated pathway ensures that nutrient extraction is incredibly swift. A healthy adult cat can typically process, digest, and fully absorb a protein-rich meal in just 12 to 24 hours. Scientists discovered in the late 20th century that cats possess a unique metabolic anomaly regarding protein synthesis. In a state of rest or fasting, a human liver will naturally slow down its processing of amino acids, conserving energy until the next meal arrives. The feline liver operates completely differently. Feline hepatic enzymes involved in amino acid metabolism are continuously locked in a state of high activity. They simply cannot turn this metabolic pathway off. Because of this permanent high gear, cats require a constant, significantly higher dietary intake of protein compared to almost any other domestic mammal, roughly 2 to 3 times the protein requirement of a typical dog. Deep within this constant metabolic cycle lies a crucial dependency on a specific sulfonic acid called taurine. For humans, taurine is considered a non-essential amino acid, meaning our bodies can synthesize it internally from other dietary building blocks. Cats, however, lack the specific enzymatic machinery required to produce sufficient taurine on their own. They must obtain it entirely through their diet. The consequences of a taurine deficiency in felines highlight exactly how vital this compound is to the intricate machinery you are observing right now. Without a steady dietary supply of taurine, typically within a window of a few months, a cat will inevitably develop central retinal degeneration, eventually leading to permanent blindness. Furthermore, a lack of taurine directly impacts the structural integrity of the heart muscle, resulting in a fatal condition known as dilated cardiomyopathy. The slow, steady 120 beat per minute rhythm thumping against your chest right now is actively sustained by the taurine extracted from their last meal, circulating quietly through their bloodstream. What's happening now, as the animal rests peacefully, is a complex balancing act of hydration. Cats originate from desert-dwelling ancestors, primarily the African wildcat, Felis libica. As a direct genetic legacy of this arid prehistoric environment, domestic cats maintain a remarkably low thirst drive. Their bodies are biologically programmed to acquire nearly 70 to 80% of their required daily water intake directly from the moisture content of the prey they consume. Because of this low thirst drive, modern indoor cats fed entirely on dry kibble, which typically contains only 5 to 10% moisture, often exist in a chronic state of mild dehydration. To compensate for this evolutionary quirk, feline kidneys are highly sophisticated water conservation units. The feline kidney is capable of concentrating urine to an extraordinary specific gravity, often exceeding 1.060. For comparison, a healthy human kidney generally concentrates urine to a specific gravity of around 1.020. This means a cat's internal filtration system can squeeze almost every usable drop of water back into their bloodstream, producing waste that is incredibly dense and concentrated, a vital survival mechanism for an animal historically isolated from standing water. Reflect on how this specialized internal chemistry translates to the larger arc of their life and the life you share with them. The average lifespan of a well-cared-for indoor domestic cat typically ranges from 12 to 15 years, though it is not uncommon for them to live well into their late teens or early 20s. The oldest recorded cat in history, a feline named Creme Puff from Texas, lived to the staggering age of 38 years and 3 days. During these years, their bodies undergo a continuous, silent process of cellular renewal. The very skin resting against your hand right now is constantly regenerating. The feline epidermis, the outermost layer of skin, completely turns over and replaces itself roughly every 21 days. This continuous shedding of microscopic, keratinized epithelial cells, commonly known as dander, is actually a sign of a healthy, functioning immune and integumentary system. Within this cycle of life, their sleep architecture reveals profound similarities to our own. You might wonder just how deeply a purring cat is actually resting. Researchers observing feline brainwaves via electroencephalograms, or EEGs, have categorized their sleep into 2 distinct primary phases, much like human sleep, slow-wave sleep, and REM, or rapid eye movement sleep. For approximately 70% of their typical 12 to 16-hour daily rest period, cats exist in slow-wave sleep. During this phase, the EEG shows large, slow delta waves. This is a light, easily interruptible doze, perfectly represented by the iconic image of a cat sleeping with one ear swiveled toward a sound. It is a state of profound physical rest, combined with high neurological vigilance. Even while napping, their brain is constantly processing the barometric data from their whiskers and the ambient noises of the room. However, for the remaining 30% of their sleep cycle, they drop into the profound depths of REM sleep. In felines, periods of REM sleep usually last for about 6 to 8 minutes at a time, occurring cyclically throughout their longer naps. It is during this REM phase that the true magic of neurological maintenance occurs. During REM sleep, the feline brainwave pattern shifts dramatically, becoming rapid and desynchronized, appearing almost identical on an EEG to a brain that is completely awake and alert. It is during these specific 8-minute intervals that you might observe their paws twitching, their whiskers quivering, or a subtle, rapid fluttering beneath their closed eyelids. Neurologists postulate that, much like humans, cats are actively dreaming during these REM cycles. The brain is busily sorting through the complex sensory data gathered throughout the day. The precise velocity of a chased toy, the spatial map of the living room furniture, the chemical signature of the air. The REM cycle acts as a vital neurological defragmentation process, consolidating important short-term memories into long-term storage while simultaneously discarding irrelevant data. Interestingly, while the brain is highly active during REM, the feline body undergoes a state of temporary muscle atonia. A chemical signal released from the brainstem actively paralyzes the major skeletal muscles. This is a crucial safety mechanism, preventing the sleeping animal from physically acting out their dreams and potentially injuring themselves while unconscious. The purr, however, often continues unabated right through this paralysis. Because the laryngeal flutter is driven by that autonomic localized neural oscillator we discussed earlier, it completely bypasses the general muscle atonia, when allowing the rhythmic hum of contentment to persist even while the rest of the body is totally immobilized. Consider how this intricate machinery relates to the rhythms of your own life. You share your home with a highly evolved obligate carnivore, possessing a battery-acid stomach, an accelerated digestive tract, and an engine fueled entirely by complex proteins and taurine. You provide the shelter and the resources, and in return, they offer this ancient 25 Hertz mechanical wave of comfort. As you observe the slow twitch of a paw or the gentle rise of their rib cage, you are bearing witness to millions of years of evolutionary refinement happening in real time. The quiet digestion of amino acids, the aggressive concentration of hydration within their kidneys, and the 8-minute cycles of neurological defragmentation are all occurring silently beneath the surface of that incredibly soft, 102-degree fur. Allow the realization of this immense, hidden complexity to deepen your appreciation for this quiet moment, anchoring you further into the peaceful, shared silence of the room. Even as the animal beside you remains deeply entrenched in their restorative cycle of rest, subtle movements occasionally ripple across their form. Observe the delicate, almost imperceptible twitch of their triangular ear. Have you ever questioned why these external structures, known scientifically as the pinnae, are so incredibly mobile? Within the base of a human ear, there are only 6 rudimentary muscles, allowing for very little, if any, purposeful movement. By stark contrast, A domestic cat possesses an astonishing 32 independent auricular muscles, controlling each pinna. This dense network of microscopic muscle fibers acts much like the motorized gimbals of a deep space radio telescope. They allow the feline ear to pivot rapidly, achieving a full 180-degree rotation. This structural geometry enables the cat to physically track the precise origin of a sound without ever needing to move their head or disturb their slumber. Investigate the acoustic capability housed within those soft, fur-lined cones. The auditory perception of a feline extends deep into the ultrasonic spectrum. While a healthy human ear can detect sound waves vibrating up to a maximum frequency of about 20,000 Hertz, a cat's auditory system is meticulously tuned to capture frequencies reaching all the way to 64,000 Hertz. This specialized range evolved for a highly specific purpose. It perfectly aligns with the ultrasonic acoustic signatures generated by the microscopic squeaks and rustling of small rodents. The resting cat is essentially blanketed in a layer of high-frequency data, monitoring a silent ultrasonic world that remains entirely invisible to human senses. Run your fingertips lightly over their immaculate coat once more, paying close attention to how perfectly aligned and exceptionally clean each strand feels. This pristine condition is the result of a biological grooming tool of unparalleled engineering. When a cat grooms itself, it utilizes the rough surface of its tongue, which is densely carpeted in hundreds of tiny, backward-facing spines called filiform papillae. Delve into the structural mechanics of these papillae. They are composed entirely of keratin, the exact same resilient structural protein that forms their sharp claws and your own fingernails. For decades, biologists assumed these papillae were simply solid, cone-shaped scrapers. However, in 2018, researchers utilizing advanced micro-CT scanning technology discovered that the very tip of each individual papilla actually features a tiny U-shaped hollow cavity. The physics governing this hollow cavity are profoundly elegant. Through the simple principle of surface tension, each microscopic scoop wicks up a precise droplet of saliva from the mouth. When the cat drags its tongue through its fur, the rigid keratin spikes easily part the dense 130,000 hair per square inch outer coat. As the tips brush directly against the skin, the surface tension is broken, depositing the saliva directly onto the epidermis. This mechanism entirely bypasses the thick, insulating layer of fur that would normally block moisture from reaching the skin. Take a moment to understand why this precise moisture delivery system is so vital to their survival. Unlike humans, who regulate body heat through millions of sweat glands distributed across our entire skin surface, cats possess eccrine sweat glands almost exclusively on their hairless paw pads. Therefore, they rely heavily on the thermodynamic process of evaporative cooling. As the expertly deposited saliva evaporates off their skin, it physically draws thermal energy away from their body. Furthermore, at the base of every hair follicle lie sebaceous glands, which secrete a lipid-rich oil called sebum. The mechanical action of the keratin papillae efficiently distributes this sebum along the length of the hair shafts, creating a naturally waterproof barrier that protects their delicate undercoat from environmental moisture. Perhaps as they rest against you, you feel the slow, rhythmic flexing of their front paws, a gentle pressing and releasing into the fabric of the blanket or your clothing. This rhythmic extension and retraction of the claws is colloquially known as kneading. To uncover the origins of this behavior, we must look back to the very first hours of their life. Kneading is an innate neonatal instinct. a nursing kitten presses rhythmically against its mother's abdomen to physically stimulate the release of two vital hormones in the mother's body, oxytocin and prolactin. This hormonal release actively facilitates the letdown of nutrient-rich milk. Even in adulthood, a cat associates this specific mechanical rhythm with ultimate safety, absolute warmth, and maternal comfort, often performing it right before they surrender entirely to sleep. Yet, this rhythmic pressing serves a secondary, unseen purpose, grounded in the complex world of chemical communication. Tucked discreetly between the pads of their paws are specialized interdigital glands. With every slow, deliberate press of their paws against the fabric, these glands secrete semiochemicals, specific feline-appeasing pheromones. While you cannot smell these lipid-based chemical markers, to the feline olfactory system, they paint the surrounding area in a vibrant, invisible tapestry of ownership and security. They are essentially writing a chemical diary into the fabric, assuring themselves that this space is secure. Reflect upon the specific shades and patterns of color that paint the fur resting beneath your hand. The striking hues of a domestic cat are orchestrated by a masterful biological loom operating at the genetic level. All feline coat colors are derived from just two base pigments produced by specialized cells called melanocytes. The first pigment, eumelanin, absorbs almost all visible light, producing shades of deep black and rich brown. The second pigment, pheomelanin, reflects light in the longer wavelengths, creating shades of vibrant red, orange, and pale yellow. Notice the intricate banding on individual hairs, particularly if the cat possesses a tabby pattern. This alternating band of light and dark on a single hair shaft is governed by a specific sequence of DNA known as the agouti signaling protein gene. As a single hair grows out of the follicle over several weeks, the agouti gene acts like a microscopic switch, cyclically turning the production of eumelanin on and off. This toggling creates alternating rings of dark pigmentation and pale, yellowish bands on the very same strand of hair, granting the animal a highly effective, natural camouflage designed for dappled forest light. If the creature beside you has patches of pure white fur, you are observing a fascinating cellular interruption. These white patches are typically controlled by a mutation in the KIT gene, often referred to as the piebald spotting gene. During the animal's embryonic development in the womb, melanocytes originate at the neural crest, running along what will become the spine, and slowly migrate downward to cover the skin. The piebald mutation effectively halts this cellular migration before it finishes. Where the migrating pigment cells fail to reach the skin, there is an absolute absence of melanin. Those white paws or chest patches are not actually colored white. They are completely devoid of pigment, reflecting all wavelengths of visible light directly back to your eye. While we admire the complex reflection of light off their coat, the cat's own perception of the visual spectrum is wonderfully distinct from ours. The feline retina is perfectly adapted for the low light conditions of dawn and dusk, a visual system known as dichromatism. Their eyes contain only two primary types of color-receptive cone cells, which peak in sensitivity around the 450 nanometer wavelength, appearing as blue, and the 555 nanometer wavelength, appearing as a greenish yellow. They lack the specific red-detecting cones that humans possess, meaning a bright red toy likely appears to them as a muted shade of gray or brown. However, their physical eye placement grants them a sweeping 200-degree field of view, significantly wider than the human limit of 180 degrees, allowing them to detect the slightest peripheral motion in the surrounding shadows. When observing their complex relationship with the invisible world, one must acknowledge the highly specialized anatomical feature known as the incisive papilla, a tiny duct located just behind their upper front teeth. Occasionally, a waking cat will pause, slightly open its mouth, and curl back its upper lip in an expression known as the flamen response. Through this deliberate muscular action, the cat draws heavy, moisture-borne odorants, like the complex steroid hormones found in pheromones, into their mouth and pumps them directly up through the incisive ducts to the vomeronasal organ. This mechanism bypasses the standard nasal cavity altogether, allowing them to effectively analyze large, slow-decaying lipid molecules that can persist on surfaces for weeks. We are surrounded by layers of reality that constantly overlap. The ultrasonic frequencies dancing in the air, the microscopic droplets of moisture regulating temperature, the chemical markers woven into the blankets, and the alternating bands of pigmentation programmed by ancient genetics. When the purring creature beside you is seamlessly connected to all of these layers, interpreting the complex physics and chemistry of the room with an effortless, resting grace. Allow your own senses to soften, absorbing the steady rhythm and the radiant warmth, finding deep serenity in the immense quiet complexity of the physical world. The process of yielding entirely to rest is a highly orchestrated biological sequence, one that unfolds gradually, step by step, in the quiet darkness of the room. Observe how the transition into deep sleep happens within the magnificent creature beside you. First, the 32 independent auricular muscles within the base of their pinnae systematically release their tension. The ears, which were perfectly and rigidly swiveled to track high-frequency acoustic data, slowly lower into a neutral, relaxed posture, surrendering their vigilance to the safety of the night. Next, focus on the deliberate, sequential closure of their eyes. As the outer fur-lined eyelids heavily shut, a secondary automated process occurs entirely out of sight. The feline third eyelid, scientifically termed the nictitating membrane, sweeps smoothly and horizontally across the cornea. This happens in a fluid, sweeping motion, distributing a microscopic layer of basal tears over the surface of the eye. These tears are not merely water. They are a complex biological defense mechanism containing an enzyme known as lysozyme. Step by step, this specific enzyme actively breaks down bacterial cell walls, effectively sterilizing and protecting the delicate optical tissue while the animal remains completely unconscious. As the external sensory organs power down, the internal thermal regulation system begins a calculated metabolic shift. The core body temperature, which stubbornly holds at roughly 102 degrees Fahrenheit during active waking hours, begins a systematic decline. Over the course of their descent into sleep, this internal heat drops by approximately 1 to 2 degrees Fahrenheit. This slow thermal reduction is a precise evolutionary strategy. By incrementally lowering their temperature, the feline resting metabolic rate decreases by roughly 10 to 15%, carefully conserving precious caloric energy until the morning light returns. Step by step, the internal rhythms begin to match the profound quiet of the surrounding atmosphere. The resting heart rate, initially pacing at a rapid 140 beats per minute, incrementally drops toward a slower, on deeper threshold of roughly 110 beats per minute. Simultaneously, the rhythmic machinery of their respiration lengthens and softens. The thin skeletal muscle of the diaphragm expands more slowly, shifting the respiratory rate from an active 30 breaths per minute down to a highly stable, prolonged baseline. Deep within the structural protection of the feline skull, The neurological sequence of sleep is physically measurable. The brain transitions seamlessly through varying frequencies of electrical activity. The biological electrical grid shifts away from high-frequency beta waves, which measure between 12 and 38 Hertz during active alertness, down to slow, rolling delta waves, pulsing at a mere 0.5 to 4 Hertz. This step-by-step reduction in electrical frequency signals the onset of the most profound stages of physical cellular restoration. This entire shutting down sequence is chemically driven by the steady synthesis of specific neurotransmitters. Within the feline brain, specialized enzymes sequentially convert the essential amino acid tryptophan into serotonin. As these serotonin molecules bind to their designated neural receptors, they effectively mute the active sensory pathways, gently and systematically decoupling the animal's conscious mind from the waking world. As this biological machinery powers down, it is a staggering endeavor to trace the atomic lineage of the materials currently at work. The physical components of this resting animal are ancient. The carbon atoms that form the structural backbone of the cat's DNA, and indeed your own, did not originate on this planet. They were forged sequentially, step by step, through the immense pressure of nuclear fusion within the cores of red giant stars over 4.6 billion years ago. The iron molecules currently binding to oxygen within the cat's slowing bloodstream were synthesized in the violent, luminous explosions of ancient supernova. The calcium reinforcing their 250 individual bones, the very bones currently being stimulated by the low-frequency mechanical wave of the purr, shares this exact celestial origin. As your hand rests upon their breathing form, you are touching ancient recycled stardust, temporarily assembled into the biological architecture of a sleeping feline, silently radiating heat into the dark room. Even the simple moisture carried upon their breath, and the water that composes nearly 60% of their total body mass, holds a direct connection to the dawn of time. Water relies upon hydrogen, the absolute oldest element in the known universe, created sequentially during the initial rapid expansion of the cosmos, roughly 13.8 billion years ago. The slow, inevitable dance of gravity pulled these ancient drifting elements together across unfathomable timescales, ultimately forming our solar system, the breathable atmosphere, and the quiet companions who rest safely beside us. Notice the physical warmth still transferring continuously from their soft coat to your skin. This heat is actively radiating out as infrared energy, a form of electromagnetic radiation, and these invisible waves of warmth leave the cat's physical body and travel toward you at the absolute speed of light. Precisely 299,792,458 meters per second. Though the physical distance between you is only fractions of an inch, the physical laws governing this transfer of thermal energy are the exact same mechanisms that govern the ancient light traveling toward us from the most distant, silent galaxies. Gradually, as the protective state of muscle atonia completely takes hold of the feline's skeletal structure, the laryngeal flutter begins its final taper. The neural oscillator located deep within the brainstem slowly dampens its rapid 30-millisecond firing rate. The 25 Hertz mechanical rumble softens, stepping down incrementally until it finally yields entirely to the silence of the room. All that remains of the acoustic symphony is the slow tidal wash of their steady respiration. The tiny 15-milliliter volume of air moves endlessly in and out, a microscopic emulation of planetary orbits, reliable, steady, and beautifully unending. Allow this gentle cessation of sound to cue your own physiological descent step by step. Sequentially release the lingering tension held within the muscles of your jaw, the weight resting upon your shoulders, and the subtle clench of your hands. As the blood pressure within the sleeping animal drops by roughly 20 to 30 millimeters of mercury during this restorative phase, encourage your own vascular system to mirror this gentle, relaxing dilation. We are all inherently bound to these massive cosmic rhythms, and the rotation of the Earth away from the light of the sun signals the pineal gland to release melatonin, initiating the exact same biochemical cascade in humans as it does in felines. The encroaching darkness of the night is not a vast, empty space. It is a comforting void, a quiet, necessary sanctuary designed entirely for cellular repair, for memory synthesis, and for profound, absolute peace. Begin to surrender completely to this restorative silence, allowing the affirmations of the night to anchor you to the heavy pull of gravity. I am grounded in the slow, ancient rhythms of the universe. My physical body is a marvel of physics and chemistry, safely settling into rest. I release the energetic momentum of the day, step by step, into the quiet dark. The atoms that form my being have survived billions of years, and they are completely secure in this exact moment. I welcome the absolute stillness of the approaching night. I am surrounded by the invisible warmth of life, protected by the quiet mechanics of the physical world. I surrender my weight entirely to the slow, supportive dance of gravity, pulling me gently downward into sleep. My breathing mirrors the silent, steady, endless expansion of the cosmos. There is nothing left to process, nothing left to analyze, and nothing left to do. I am stepping softly into the comforting void. Rest arrives easily, folding softly around my senses like a heavy, perfect blanket. I yield completely to the profound healing silence of the stars. Good night.